Now let's talk about spanning tree. Once upon a time, there were these two computers. These two computers were operating on their own, and someone came along and said, you know, it would be nice if these two computers could talk. So, what can we do to make them talk? We put a cable in between the two of them. We've talked in the past about the fact that if you want two devices that are like devices to communicate with one another, we use what's referred to as a crossover cable to cross the transmit and receive wires. However, along came this third guy over here, and he decided, hey, I want to get in on the action. I want to talk as well. So, in order for that to take place, some other mechanisms had to be invented to make it possible for all of these computers to talk. This is where we get the concept of coming up with devices such as a hub. So we throw in this hub and we make it possible for all of these devices to communicate one with another. And basically all the hub is a layer 1 device that extends the actual physical wire here. So the hub can be thought of as a wire. In networking diagrams, what you find is that we'll draw a picture of a router, and then you'll see something like that. This little picture right here, we'll call it a wire. Sometimes we'll give that wire an IP address, a network address, 10.1.1.0. We'll say that that's the wire's address. Basically, what's being said is that this is a segment. This is a segment right here, a physical segment. And so in networking diagrams and possibly in some of the curriculum, you'll see this hub represented really as just a wire. But basically, what we really have physically here is a hub. So we've got this hub right here that's making it possible for these computers to talk. And over here, we've got another network, another segment, and we've got some computers on this segment as well. The two of these hubs are connected to one another. All of this still is one big segment. The problem is, the larger that this environment gets, the more we run into a problem of collisions. Collisions are a layer 1 occurrence that happens when you've got too many devices in one common collision domain or one common wire, because only one of these devices can talk at any one given time because of that carrier sense multiple access collision detection thing. Now, you got this one big collision domain. The larger this environment gets, the more collisions that you have. So what do? Well, to fix that, we go to a layer 2 device called a switch. We put this switch in there. Now, with this switch, each port on the switch is a separate collision domain. So, got a collision domain over here and collision domain over here. And these are referred to as segments. This is segment 1. And this is segment 2. The problem now, though, is that in order for the communication to take place between segment 1 and segment 2, they have to go through a common device, this switch right here. And this switch right now, this is a poor network design because this is what we refer to as a single point of failure. So what do? We put in another switch. Put this second switch in here. And so now we have more than one path between segment 1 and segment 2. This makes it possible for switch 1 here to go down, and we still have another path, a redundant path, so that segments 1 and segment 2 can still communicate with each other regardless of the failure or the fault. This is what we also refer to as fault tolerance. So now with switch 1 and switch 2 here, we have what's referred to as a redundant topology. A redundant topology is a very good thing, a very necessary thing, as you can see, in order to eliminate a single point of failure. However, redundant topologies introduce some other problems that we're going to talk about now. One problem that occurs with redundant topology is the problem of broadcast storms. You'll recall that switches, that even though these are two separate collision domains here, one collision domain in segment 1, one collision domain with segment 2. In spite of the fact that we have two separate collision domains, this is still one big broadcast domain. Okay? So we've got one big broadcast domain here. So Say, for instance, device A up here sends out a broadcast. That broadcast hits the hub. Remember, the hub being a layer 1 device, it's a dumb device. And so therefore, the hub is simply going to repeat that broadcast frame out of every port other than the one that it came in on. So that goes out to each device here, which includes going to this switch. So that broadcast frame hits the switch. Well, what do switches do when they don't recognize the destination address? What switches do is they flood. They flood the frame, which means that this switch will send a copy of the frame out of every port other than the one that it came in on. So that means this broadcast frame is now sent out of this other port and hits this hub on segment 2. Well, remember, the hub, being a dumb device, is going to simply repeat it out of every port, which means it'll be sent up to switch 2 right here. Switch 2 also does not recognize the destination address because it's a broadcast address. And what do switches do when they don't recognize the destination address? Well, they flood. So this switch is going to send that out of this port right here, which it'll hit the hub again. That hub will repeat. It'll hit this switch again. That switch will flood. It'll continue doing this, and it'll continue this loop until eventually you've actually eaten up all the bandwidth on that network, and the ports on the switches will eventually just shut down because of what we call a broadcast storm.